Types of chemical reactions. There's 5 types of chemical reactions that we review. Synthesis reactions, decomposition reactions, single replacement reactions, double replacement reactions, and then combustion reactions. So let's first look at synthesis reactions. Essentially, in a synthesis reaction, you're taking 2 or more simple elements or compounds. In this case, they're using A to represent one element and B to represent another element. And then the reaction, which I'm using the arrow here, showing the reaction is going to the right, produces a product AB. So A and B on this side, those are reactants, and AB is our product. So we're doing a synthesis reaction. We're taking simple elements or compounds and putting them together to make something more complex. An example is the production of water. We have oxygen, O2, and hydrogen, H2, which is combined in a reaction to produce water. Another reaction is we have iron, 2Fe, and then oxygen, O2, and we combine those to form iron oxide, 2FeO. So really we're going from simple to more complex. Right? We're combining elements in these examples here. A decomposition reaction really is the opposite. We're taking the more complex compounds and we're breaking them apart into their pieces. So in this case we have AB, which is representing a compound, and in this reaction we break those apart into their simple components, A and B. So again, A represents one element, B represents another element. In this case, our product, so this is our reactants. Our product is A, which represents one type of element that is separate now from the second element, B. An example is the opposite of what we saw in our synthesis reaction. We're taking water and we're breaking it down into hydrogen and oxygen, so 2H2 and O2. Another example is calcium hydroxide. We have CaOH that's combined, and what we're doing is we're actually breaking down the carbon and oxygen and hydrogen. So we have a more complex molecule on this side, and we're breaking up into 2 simpler molecules on the product side. Another one is sulfuric acid. We break that up. We take that. It goes through a reaction where you're breaking it down to simpler SO3 and water. Now we have a single replacement reaction. So on a single replacement reaction, an example would be A plus BY. You have a reaction, and it yields AY plus B. So if you look on this side, you have the A element. There's no Y there. We have B with the Y. And our product side, the A is now combined with the Y, and the B is now a single element. An example is we have aluminum and iron nitrate, and that yields iron and aluminum nitrate. So what we've done is we've taken the nitrate and moved it from the iron on this side of the reaction, and on the product side the nitrate is now with the aluminum, and the iron is now elemental. Another example is chlorine. So we have chlorine as a gas, plus potassium bromide. And you can see the potassium I put in red, and in the case I also put the nitrate in red in this reaction up here. So the potassium, if you watch it, potassium is combined with or bonded to the bromine, but on the product side, the potassium is now combined with or bonded to the chlorine. And then we have bromine as just a diatomic molecule. In a double replacement reaction, you're actually doing two, you're switching two different elements among the compounds in a chemical reaction. So if you look, you'll see AB on the reactant side. So again, A is one element, B is another element, plus CD. So C is one element, D is another element. In our product side, the A is now combined with the D instead of the B, and the C is now combined with the B instead of the D. So you've seen there's two elements that have swapped places, if you will. In other words, there's two substances or two parts of the compounds that have been replaced. Another example is you have iron sulfate plus hydrochloric acid is going to yield H2S plus iron as FeCl2, iron chloride. So if you look on the reactant side over here, you have the iron combined with the sulfur. If you look on the other side, the iron is now combined with chlorine. On this reactant side, hydrogen and chlorine are bound together. But on the product side, the hydrogen is now combined with sulfur instead. So it's our double replacement reaction. Then finally, combustion reaction, which is very similar to a decomposition reaction. But the difference is that in a combustion reaction, you have a substance combines with oxygen. Remember, oxygen has a very high electronegativity. So oxygen likes to combine with elements and take part in the oxidation reaction. So it releases a lot of energy. So if you look at C3H8 plus 5O2, you're going to see in this reaction it yields C3O2 and 4H2O. So this is common in combustion reactions, is that you will see an organic compound combines with oxygen and it yields carbon dioxide and water. So if you see a product that consists of carbon dioxide and water, even if there's other substances as well, that's really a hallmark of a combustion reaction. And you have oxygen that's going in. So oxygen is the oxidizer. So this is a combustion reaction. So for instance, in an example that we are exposed to every day is if you are going in an automobile that burns either diesel or gasoline, you will see carbon dioxide and water being as a byproduct. And that's why on cold days, when a car first starts up and the tailpipe is cold, you will see water dripping out of the tailpipe of the car, because that's actually water from the combustion of gasoline that's collecting in the tailpipe. So when the tailpipe is cold, the water vapor will condense on the sides of the inside of the tailpipe, and you'll see it dripping out. When the car gets hot, the pipe gets hot, and you don't have water condensing on anymore. So that's why that occurs when the car is cold. All right, thank you.